We've looked at the different set operations that we have available to us. Remember, these are just ways to take and join sets in some way. We have the intersection, which is the collection of all elements that are in both of two sets. They don't have to be called A and B. We're just generically using this definition. It could be called D and W. Then the union, denoted A union B, is the set of all elements that are in A or B. And what I want you to take away from this is that A or B, by the definition of the word or, means only in A, only in B, potentially in both A and B. So when we look at these Venn diagrams, I'll just quickly sketch these off to the side here. The intersection between two sets is going to be the overlapping portion that they share in common. The union is going to include that region as well, but it's also going to take into account where an element is just inside of A or just inside of B. So here we are in both. Here we are just in A, and here we are just in B. So it's basically taking all of the elements and putting them together. So when two people form a union, they take all of their belongings and bring them together, omitting duplicates usually. The complement is the set of all things outside of that set. And remember that this container, this Venn diagram, represents the universe. So that's the universe. In all of these, usually we don't label it that way, but just for reference so that we know that everything inside of A is everything inside of that box, but everything outside of A, or what we call a complement, is everything surrounding A, excluding A. And then the set difference is the set of all elements that are in A and that are not inside of B. So what you can think of that as being is that's basically just A. A minus B, or the set difference between A and B, is the elements just in A. If we did B minus A, all the things in B and not in A, that would be B only. So one thing that we want to often be able to do is visualize when we have multiple sets being combined in some way, what area of a Venn diagram are we actually talking about? So far we've considered these basic ones, but we can combine these different features. We can have intersections and unions, and things can get a little bit visually or dynamic, and so we want to have a simple way of representing that. So, for example, what would A complement intersected with B look like? For the remaining examples, let's think about this context. Let's say that A is the set of all students taking art, taking an art class. B, we'll say, is the set of all students taking biology. Say that C is the set of all students taking chemistry. Okay, so you could be taking more than one, right? Just because you are taking art, that doesn't mean that you are or are not taking biology or chemistry. So in the case where we only have two sets, of course we don't need to draw set C because we're only focusing on relationship between A and B. But what would it mean to say A complement intersect B? Well, let's put this into more basic words. Complement means not in, right? So this is the group of students who are not art students and who are bio students. Okay, well that means I can't be in art, so I can't be in this circle, and I do have to be in biology, which means I have to be in the B circle, but not in the portion that it overlaps with A. Because the portion that is overlapping between A and B is the set of all students taking both art and biology. So if you read it that way, I am not taking art and I am taking biology. That means I'm somewhere in this set right here. That means that person lives in that set, or that element lives in that set, that region. Okay, we can take three sets and do kind of the same thing here. And we can, with intersections, read it very intuitively. We can say, where are the students who are taking art and are not taking biology and are not taking chemistry? Well, it means I have to be in the A circle. This element lives in the A circle, but not where it overlaps with B and C. So you're only taking art. Okay, well, that's just the portion of A that has nothing in common with B or C. Simple as that. Okay, we don't want to include this portion here because that would be art and biology students who are not taking chemistry. This is taking all three. This is taking chemistry and biology, and this is taking just art and chemistry. But we just want students taking art. Now, we can't just say A, The distinction here is if we say A and you're like, well, wouldn't that be the same shading? No. A is all of A, regardless of what overlap it has with other sets. So if we want to specify that we want just art students and we know there are 3 different groups of students, we have to say, okay, you are an art student, but you aren't a biology and you aren't a chemistry, allows us to isolate that region. So if you're dealing with multiple sets, you have to state where that element lives with respect to the other sets as well. So if we didn't include C in here, then we'd really just have to focus on the circles of A and B and wherein that relationship lies. Okay, here's another one. This one combines intersection and union, and there's lots of different ways to do this. One way is to just shade what's in the parentheses first, and then shade what's outside of the parentheses and see what they have in common. This is going to be the overlap between A and B union C. Okay, so I am in A. I'm going to do this in a different color, and I suggest that you do the same. The highlighter here. Okay, I'll shade A like this. So we are in A. That's all of A right there. And then I know I can shade B union C because that's by definition is the everything that B and C have in common, right? So that's, or not in common, excuse me, it's just in B, just in C, or potentially in both B and C. Okay, so we get a good shading in here so we can see it all. And now what are we looking for? We're looking for the overlap between the blue and the orange, which is precisely just that green region. So our final shading should only involve, notice it should just be this triplet of regions right here, and right here. Okay, well, how could I intuitively read that? Well, this is saying that I am in art and I'm in biology or I am in chemistry. So that means I have to be in art and biology, or I have to be in art and chemistry, right? Because I have to be in art and I have to be in one or the other, or both of biology and chemistry. So that, notice, incorporates where A overlaps with C, where A overlaps with B, and then of course naturally that will include where you're in all 3 of them. All right, let's look at one more. What about this guy here? So here we're looking for students who are in art, or they're not in biology and they're not in chemistry. Okay, well, I'm going to start with A, of course. A, we know, is that orange region. So once again, I'll come back and just shade that orange region. Okay, and then I have an operation, so that's why I'm going to change. That's why I'm going to change colors now. So there's A, and now let's go with, use this blue. And now I'm going to look at B complement and C complement. So who are these students in that blue? Well, that's going to be people who are not taking biology and who are not taking chemistry. So the people who are taking biology and or chemistry would be all of the blue circle, all of the B circle, and all of the C circle. But I want all of the students that are not in those 2. Okay, well, that would be everything outside, by definition, outside of B and C. This blue part doesn't say anything about A, so to simply be outside of B and C would mean you are outside of the B circle. That could be all of this region. Okay, all the way around here, and outside of C as well. Okay, now it doesn't say anything about A in that blue portion, so that's going to be all of this excluding. The only thing that's excluding is all of the B circle and all of the C circle. Now, because I'm dealing with a union, I'm looking for where there's just blue, where there's just orange, or where there is both orange and blue, right? The word union means just in one, just in the other, both. Okay, what do we mean by that? Well, in this case, to be just in A means you're just in B complement intersect C complement, you're just in the blue, and to be that you are in the overlapping portion, which is the green. Okay, so that means by the definition of union, I'm going to take anything that has blue, anything that has orange, and combine those together. So that means the only parts that will be unshaded are the parts that are already unshaded. Right? We don't actually need to, like over here with an intersection, we were only looking for the overlap. With a union, we're just taking it. Anything that's shaded is part of the Venn diagram. So that's going to be all of the shading. All of the regions. I'll just say any shaded region. And here we're just looking for the 3 center pieces. Okay, well it turns out that there are actually some properties, what we call identities, and there are many of them out there. 2 of them are what we call the distributive identities, which a cool thing that we can actually do is if we have an intersection between a set and the union of 2 other sets, notice how the A set distributes to both the B and the C. So that if that is an intersection operator here, the way the A distributes to the B is via an intersection, and it distributes to the C via an intersection as well. And if you were to shade the corresponding sets in this right-hand side, you would notice that you would shade exactly the same thing. These aren't things necessarily you need to memorize. This could make things easier to shade. Maybe it's a little bit easier to shade A intersection B, because we know that that's the part where A and B have in common. Where A intersects C, shade what those 2 have in common, and then notice that we still end up with those 2, with these 3 regions right here. Also, same thing applies with the distributive property over a union. The only difference here is that if you distribute set A to B, it becomes A union B, and then you're distributing over an intersection, and then you'll have A union C. So that just is a helpful identity sometimes if you want to expand things out and see this in terms of the unions of 2 intersections versus the intersection of a union. Just useful properties to have stored away somewhere. Now, another thing that we deal with is sometimes we have strange types of complements where, for example, in this case, notice that it's the complement of A union B. Okay, complement means outside of. Now, A union B, we already know, would be everything inside of A and not in B. Everything that they share in common and things only in B. That would be A union B. Okay, but we're looking for everything outside of A union B, right? So that means take A union B, unshade, and then shade in the portions that are not shaded in A union B. So in simple terms, okay, we know that A union B is everything in those 2 circles. So the complement of that would be everything outside of A union B. Okay, similarly, A intersection B is everything in the center portion. So if you are not in the center portion, that means you are somewhere else, right? We don't know where, but if you're not in A intersection B, you could be in just A, you could be in just B, or you could be in neither of those 2 sets. So it's basically like you take an image that's black and white and you do like a negative of it. It'll take the blacks and make them whites. It'll take the whites and make them black, and will produce the same image but just with kind of inverted colors. So that's exactly what a complement does, is it inverts the shading. Okay, this actually resonates with what we call De Morgan's laws, and De Morgan's laws say that if you negate a union, it's the intersection of the set complements. Let's put this in terms of art and biology. It is not the case where I am not in art or biology. Well, that means that I'm not in art and I'm not in biology. I'm not in one or the other. Simple as that. Here I'm saying A intersect B complement. I'm saying I am not in both art and biology. Well, that means I'm not in one or I'm not in the other. But I'm in neither of them, but I'm just not in both of them. And so I think those are pretty intuitive properties as well. Now, let's look at a couple more little examples. What about A complement and B union C complement. Let's make this really easy on ourselves and actually use De Morgan's law. And we know that the complement of a union is, well, it's going to be the complement of the first set intersect complement of the second set. So this is equivalent to A intersection, okay, B union C complement, we know we could replace with B complement intersect C complement. Just have to make sure we're using the right labels. And then technically we have that parenthesis there, but notice that this just says students that are not in art and not in biology and not in chemistry. And hey, that's actually exactly the same thing that we looked at back in number... oh, no, we didn't look at that one. But it's very similar to number 2 now, where I just have to think about where are the students that are in none of these classes. Well, that's going to be everything outside of those 3 circles. It's not going to include anything in the 3 circles because I'm not in art, I'm not in biology, I'm not in chemistry. So the element has to live there somewhere in that range. Okay, now it turns out, to wrap all this up, if we have 3 sets, we can label all of the regions, every single region in terms of A, B, and C. And remember how if we have 3 sets, we always have to state regions in terms of all 3 sets. So notice in terms of the number of regions that we have one region here, we have a second region here, we have a third region, a fourth region, fifth, sixth, seventh, and eighth. We have 8 total regions with 3 sets. Let's label all these regions art, biology, and chemistry. Well, region 1, we're not in any of them. So we're not in art, and we're not in biology, and we're not in chemistry. And is really easy because we know exactly what we're talking about when we're dealing with intersections. With unions, it's a little trickier to do this, but the beauty is we can use intersections to label all of these. Region 2 means I am in art, and but I'm not in biology or chemistry. So that's going to be art and not in biology and not in chemistry. Region 3, we are both in art and biology, but we're not in chemistry. Art, biology, not in chemistry. Region 4, well, that would be just in biology. So yes, biology, no art, no chemistry. Region 5, well, that's an overlap between art and chemistry, but without the biology students. So we are in art, we're not in biology, we are in chemistry, and we're looking for the overlap between those 3 regions. Region 6, we're in all 3, A and B and C. Region 7, we are in biology and chemistry, but not in art. And region 8, we are only in chemistry, we are not in biology, and we are not in art. And so that's how we could label all 8 different regions. So notice how it's important to have all 3 letters in that intersection so that we say exactly where those elements are in relation to all 3 sets. If we said something like this, A intersection B, well, then we have to ignore set C as if it weren't even there. So A intersection B would be regions 3 and 6, right? Because we're not saying in this statement whether a student is in chemistry or is not in chemistry. If I say, hey, go out and call all art and biology students, you're not going to not call the chemistry students, and you're not going to not call the students that aren't taking chemistry as long as they're taking both art and biology. So that's why we have to specify every single region in terms of all 3 sets, because regions 3 and 6, although we are in both art and biology, it's a different story in terms of whether we are or are not in chemistry. So we can say A intersect B, but that actually encompasses 2 different regions here.